So I'll leave this on, okay?
Yeah, we're on.
Awesome.
Okay. Hello and welcome everyone to another session of Angie Asia, where we connect the Angular community across Asia and beyond. Today's topic is one that's essential for any Angular developer, performance optimization. Whether you are building large scale enterprise apps or lean front ends, improving performance can make a huge difference in user experience and the scalability. We're honored to be joined by a very special guest, Sonu Kapoor. Sonu is an Angular GDA, Microsoft MVP, book author, LinkedIn top voice, and organizer of a Toronto Angular meetup. He also co-hosts Tech Talks and the Angular Catch Up and is well-known speaker in the global developer community. Today's he will walk us through practical strategy to boost Angular performance from a change detection to lazy loading and beyond. Always feel free to drop your question in that live chat. We will have to QA at the end. So let's get started. Please welcome Sonu Kapoor. Sonu, you can start.
Yes, hi. Well, thank you so much for the very lovely introduction. Appreciate the nice words. So yeah, hello everyone. Thank you for joining the session today. So today I'm going to dive into the practical techniques to essentially run Angular applications super fast. And I believe at the end of this presentation, you should be able to apply most of the things within a matter of days. So let's just get started. Uh, Performance is not really an option or an optional anymore, right? A delay of a few seconds, right, can cause a drop in conversations or in conversions, and poor performance can also hurt your SEO, user retention, accessibility. All of those are big problems um, that can lead up to when your performance is low. So Angular gives us the tools we need to fix those issues. And with the time we have today, we'll focus on three main areas, which is lazy loading, change detection strategies, and signal-based state. Before we get started, let me just quickly introduce myself as well. My name is Sonu. I'm a senior Angular developer consultant. I mostly work with various top Forbes 100 companies and help them with their Angular projects. And like earlier mentioned, I'm also a GDE, MVP, and I host a couple of podcasts as well. So let's get started with Angular routing. So one of the great features Angular provides out of the box is lazy loading, which essentially boosts your performance by by making your bundle smaller. Okay, and how it works is that it's a very powerful and simple technique that allows us to delay the initialization of certain parts of um, our application until they actually need it. So instead of loading everything at once, lazy loading lets us load feature modules or now standalone components in smaller chunks. So this approach offers many benefits. Like it can reduce the bundle size and speed up the initial load time. And with each lazy loaded module or component, Angular separates the JavaScript file chunk. So that means the user only has to download the most essential resources initially. And if we want more control, we can use preloading strategies. that will help you to dictate which resources should be preloaded. Now, let's illustrate this concept with the following example. Imagine you have a route configuration that includes several components and they're all eagerly loaded. So that means every time someone accesses the application, all of these components are loaded right away, right? So regardless of whether the user goes through that route or not, they will always be loaded. And in that scenario, every component gets also bundled into this main chunk here. Okay. And so if we decided we wanted to implement lazy loading, the only change that is required is to adjust your routing configuration. So for standalone components, you can just simply use load component. And for modules, you can use load children. And that's the only thing you need to do. And now if you were to replicate the same number of components from earlier and lazy load them, and build the application, you will see a huge difference. You'll notice here that the main bundle size has decreased by 50%. So now it's only at 26 kilobytes. Previously, I believe it was 58, right? So it went from 58 kilobyte to 26. So that's a huge gain right there with a few steps in your routing configuration. The next thing is, lazy loading is actually quite known and very effective, as you can see. There's another technique that you can use to further boost performance, which is called the preloading strategy. So preloading is a feature that allows us to load resources in the background. And that can happen while the user is doing something else. You just preload them in the background and the user doesn't even notice it. And the good thing about thing is that the user doesn't have to go to the specified route or activate any route to do that. And this means that even while the user is engaged, with one part of the application, you can quietly fetch the resources they might need next. And by combining lazy loading with preloading, we can achieve, almost like the best performance and user experience. So our initial bundle will be small because it will contain only the most important code because we're lazy loading. And then the remaining bundles will be loaded in the background using the preloading strategy. So how does this work? So in a module-based application, implementing this is as simple as using the preloading strategy property and setting it to preload all modules. So this configuration allows Angular then to automatically preload these lazy loaded modules when the application is up and running. And for standalone components or applications, all we need to do is add with preloading to the provide router function within your application configuration. Yeah, so to sum it up, the key points about routing is I won't dive into more detail since it's a well-known feature, but we can't overlook, when discussing performance like this. Awesome. So let's talk a little bit about change detection. So change detection in Angular, as we know, is very resource intensive if it's not handled correctly. And one of the most effective techniques is optimizing the strategy and utilize the signals. And in this section, we'll explore how to do that. But before we dig into those kind of strategies, right, let's try to understand how the change detection process works. Like just in general, to make the long story short, The process involves essentially two stages. The first stage marks the click the click component as dirty, which tells Angular, hey, this component needs a checkup. Then the second phase is when Zone.js comes into play. So Zone.js is a library that monitors various asynchronous browser activities, such as XHR requests, DOM events, timers, intervals, timeouts, and so on. So you could think of this as a thread local storage for JavaScript VMs. Now, while Zone.js can monitor all the states of sync and async operations, Angular additionally provides a service called ngZone. So this service creates a zone named Angular to automatically change or to automatically trigger change detection. For example, when a button is clicked or an async function is executed, right? And when this event happens, ng essentially, prompts it to initiate the change detection. And in that stage, Angular captures an event through the micro task observable, and then traverses the entire view tree to detect and propagate any changes. And when it's time to determine what should be checked during this process, Angular relies on different criteria for checking components, like inspecting various flags that are associated with the view and its mode, right? To determine if any update is necessary. And if then the update is needed, then the component's templates gets updated by the refresh view method. Okay, so now that we kind of understand how change detection works, let's look into the different strategies. So in Angular, there's only two strategies for now. But when we spoke with Minko about it last time in the Angular podcast, he mentioned that there might be a third one, which would be tied directly to Angular signals. So we'll have to wait and see. Okay. Yeah, so by default, Angular change detection triggers unnecessary checks and updates throughout the entire application. And that's the default strategy. And it relies on the flag called check always, which essentially tells Angular, hey, check everything, right? Regardless of something has changed or not. And you might think this is great and works, so let's just use it. But it is very overkill when it comes to performance-sensitive applications. So to make things faster, then Angular introduced the on-push strategy, which only checks components when their input reference changes. And we mark components to check using mark for check method, or an event occurs like an asynchronous HTTP response, right? So that means, instead of refreshing the entire component tree, we only render the component that that is directly affected by the change and all of its ancestors up to the root. So what we're saying is we're just focusing on a specific branch of nodes in the component tree rather than the entire component tree, right? So this is how on push works. Now, I guess the question is, here we're still checking the entire tree and so on, but can we do something better? And this is where signals come into the play. So in this next section, I'll talk about Angular signals and how they can make your applications essentially faster and simpler especially if you're using, something like behavior subject or any other RxJX to manage your state manually. So let's first start asking the big questions. Why do we need signals? Like we have already change detection, it works okay, it checks the tree. Why do we need it, right? Why not just stick with behavior subject, observables, async pipes, which are pretty good, right? Um, why do we need signals? So RxJS and observables are really powerful. We know that. There's no doubt. But I think they can be a little bit overkill for simple use cases, right? So you often end up writing a lot of boilerplate code just to track state, right? You have to subscribe, unsubscribe, next, use maybe pipes, like the async pipe. You have to use the pipe operators. So there's a lot going on in there sometimes for simple tasks, right? And the catch, and here's the biggest catch is that RxJS isn't really directly tied with Angular's rendering system. Okay. So that means when a value changes, Angular has no clue, right? So when something in RxJS happens, Angular has no clue and has to guess um, whether it has to re-render, right? And often triggering more change detection than needed, right? Because there is no direct connection. So in large applications, as you can imagine, this can lead to performance bottlenecks. So Signals fix this by being part of Angular's core reactivity model. Okay, so what that means is when a signal changes, Angular knows exactly what part of the DOM to update. So there is no more check everything just in case, right? It's really precise and it's very fine-grained. And on top of that, there is no manually unsubscribe. You don't need like async pipe. You don't need to call change detector ref, you know. Angular knows when and where the change happens. So in summary, Signals lets you write much cleaner, simpler, and more performant code, especially for local and UI bound state. Now, I would say is that for global streams like WebSockets, or for WebSocket connections or event buses, RxJS is still the way to go. But for component-driven UI state, Signals are a much better tool for that. So now we know why signals matter. Let's quickly take a look how to actually use them. So here, this is one of the simplest examples, creating a signal inside a component, right? So here, we're defining a signal called count and initializing it to 0. To update the value, we call update, okay, and pass a function that receives the current value. It's like you can say the next in behavior subject, but it's way more ergonomic. So where would you use this? Think about counters, toggles, simple form states, any local UI state where you need to show hide something, right? Um, so this is where you don't want to over-engineer it with RxJS. And again, notice here there is no subscribe, no unsubscribe, there's no cleanup. Angular knows when this count changes and will automatically render anything that depends on it. Okay. So this declarative style makes code easier to reason about, and the rendering is scoped to the parts that actually read the signal. So what do I mean when I say read the signal? Okay. So to do that, let's connect the signal to the template. So notice here how we're using count as a function, right? So count is not a property. Signals are functions, and you call them to get the current value. So this ensures Angular knows you're reading the signal, okay? So why is that important? Because when you read it, Angular's reactivity system tracks that read. So if count ever changes, Angular knows where exactly or which part of the DOM to update because it knows where it was read from, right? So it knows the exact spot in the DOM in order to update it. Okay, so there's no more like running change detection across the entire component to figure out what to update. So you can think of it like almost automatic dependency tracking. Angular's reactivity is built into the template. And I would like to highlight again, compare this to using like async pipe, where you still have to manage, maybe the observable stream or even rely on like zone-based change detection. Here, I think it's a direct, it's minimal, and it's much faster. So let's go one level deeper with real world, UI scenario, filtering a product list, for example. So here we have two signals, filter for the user search input and products for the product data. So the interesting bit here is filtered, which is a computed signal. So this is how we build derived state. So when filter or products change, filtered recalculates automatically. Now think of this, how many times you have to wire up a pipe with the map operator on a behavior subject just to transform state. So now you don't need to do that anymore. This is more like Vue's computed props or Solid.js, just with Angular's type safety and DI support, right? And you can bind filtered now. So this filtered, you can bind that directly to the template. So when the user types in a search field, only the relevant rows will be rendered. This filtered is here another signal. A common a question that I always get is, can we use signals in the services like we do with behavior subjects? And yeah, you can absolutely do that. So here is a user service holding the current logged in user, which is private. So this is private, and then we're holding the user here. And the actual signal holds the state. So we expose a read-only computed signal user. So components can read it, right? Reactively, but not mutate it directly. So this replaces a behavior subject. And for example, where you would have a get user as observable with something much, much cleaner. And when you call set user, any components that read from this user will automatically update. So that you can see here, there's no emit, there's no pipe, there's no subscriptions, nothing. So this kind of pattern works beautifully in real world applications. You can imagine this being used in a nav bar, for example, to show the logged in user's name, or conditionally showing logout buttons, right? Okay, so let's wrap it up with why this actually matters, especially for performance. So with traditional RxJS and Angular, every little UI event could trigger a broad change detection cycle, even if just one item is changed. And Angular didn't know always where, right? So it played it safe and ran a check on the entire component tree. So Signals solved this by providing fine-grained change detection. So if a signal changes, Angular knows exactly what DOM bindings to update, and nothing else needs to re-render. Okay. And also, no subscribe, unsubscribe means less memory, like churn and cleaner logic. You're not really juggling async emissions or worrying about leaks, right? And thinking about, did I subscribe, did I unsubscribe, things like that. So this becomes crucial in large applications. Like if you have ever debugged performance issues tied to zone triggered re-renders or async emissions, I think you'll appreciate the precision that Signals offers. So the big takeaway here is that Signals are simpler to write, easier to understand, and much, much faster. Again, especially for UI bound state. So let's quickly recap what we covered today. So we started with routing strategies using lazy loading and cut down to initial bundle size and explored preloading and balance speed with user experience. Then we looked at change detection, especially the power of on push, to avoid some unnecessary DOM work. And finally, we took a deep dive into Angular Signals, which lets us write reactive and much more performant code without relying on RxJS. Especially useful in services and components where sometimes subscriptions can get really messy. So if you're building a large application, or even smaller ones, right, where startup time matters, I think these techniques can make a real difference. And that's all we had for today. I hope you found these tips helpful and useful. And as always, feel free to reach out to me on LinkedIn, Twitter, if you have any questions on this. Thank you.
Yeah, we have many questions here in YouTube chat. Okay, first question is, what is the biggest performance issue you have personally faced in a real Angular project?
So most of the time is when components become too big and they're doing too many things, right? I think developers sometimes forget that it's easier if you divide your components into smaller chunks of pieces that essentially follow the solid principles, right? Separation of concerns. So separate them into smaller components and then try to use on push change detection if you're not using Signals yet as much as possible. So you have presentation layer and essentially smart components, right? Smart and dumb components. So that's the biggest concern I've seen, where too much logic is packed into a single component. It's doing way too much. It's hard to follow. And this can be very difficult and performance intensive, especially when you're using RxJS on top of that.
Okay. Second question is, what's your strategy for dealing with the third-party libraries that negatively impact performance?
Hmm, that's a good question. Um, so with third-party libraries, yes, you have to be really careful when it comes to performance. You have to make sure that you first run maybe like a local test and see if those third-party libraries are really up to par with your application itself, right? If the third-party library is bringing your performance down, then it might be good idea to actually not even use it. Maybe try to implement something on your own, right? Um, there isn't really much you can do when it comes to third-party libraries because you have very little control over them. Um, if you know how to fix them, you can try to opening a PR or something if this is open source. But most of the time, it's very difficult to get these kind of things resolved very quickly. Okay. So I would say do your due diligence, do your research, and if you can, use your own implementation. Try to avoid libraries if you can.
Okay. Next question is, how can we fine-tune Angular's Zone.js or use alternative like NGRX component or uh, RxJS Angular? Yeah.
Hmm. Um, don't use it. Don't use NG Zone
Yeah.
anymore, right?
Yes.
NG Zone is going away, right?
Yeah, yeah. Yeah.
It's I think in the next version, it's going to be the default that it's turned off, right? So
Mhm.
I
Yeah.
would say try to not use it anymore at all. Like even in my previous applications, I have luckily never used NG Zone or very rare, and I never relied on it. So most of my components were using on push wherever possible. And try to, like I said, try to reduce my component size, my service size into smaller chunks, right? So that helps me to manage my performance, my memory, everything. It becomes a lot cleaner if you have a strong foundation um, to work with your application. If you have to use ngZone, like you could try using um, ngZone's functions, like run outside Angular zone, things like that. But my general suggestion would be try to avoid those as much as possible.
Yeah, they should upgrade the project.
Yes, you need to upgrade, especially you need to keep in mind that Angular does not support older versions of Angular anymore, right? So uh, like it's in your best benefit to upgrade as quickly as you can because your application and your user base will benefit from that in a very big way.
Yeah. Okay, thank. Next question is, in micro front-end architectures, how do you isolate and optimize Angular app performance?
Hmm. Okay. So unfortunately, I don't have a lot of experience with micro front end. So you mean module federation? Is that the question? Is that
Oh,
what
no, micro front-end.
micro
Uh,
front end? Yeah, yeah. Okay. What you could try is, like all the things I've mentioned, but also you can try is like working with modular based um, patterns, right? So if you have a modular based pattern, for example, if you're using NX or something to separate your libraries out into different chunks, that will help you a lot, right? Because you can set boundaries, you can set which components rely on which services or on which libraries. So that will keep your bundle really small. And then on top of that, like I mentioned earlier in my presentation, right? If you strategize those components in such a way that you can lazy load them without them being interdependent, right? Then you get the best performance. But you really need to, I think you really need to architecture your application in such a way and start thinking right from the beginning how you can separate everything out in order to get the best performance.
Okay, and the last question, I think you already answered it. Even I will try to read it. How do you balance developer experience and the performance when making architectural decisions?
Yeah, that's a good one. It's difficult, right? Like I'm the way I'm understanding this, I think it's more about business and performance, right? Sometimes business does not really care much about refactoring code to get the best experience, but
Yes.
they want the next big feature to be out so that the users can use it. Um, it's difficult. It's a fine line where you have to speak to your managers, the stakeholders, and everybody that has the power to make these kind of decisions, right? You need to speak to them and tell them um, that your productivity is suffering because of the performance or because of the version of Angular you're using, and you're not using maybe the latest version, and you're lacking those features, right? If you make a good use case for that um, to your to your colleagues about how, for example, upgrading or fixing certain things can improve the developer experience, right? I think this is a win-win for everybody because essentially your developers get a lot happier, right? Because they are allowed to work on the latest product or the latest framework, and the company will gain from it because the application will now perform a lot faster, right? So the user base is going to be a lot happier or more satisfied than before.
Mm. Yeah, okay. Um, okay, we will finish, and let's bring us to the end of today's session on Angular performance optimization. A huge thanks you to Sonu Kapoor for sharing such as valuable insights, practical tips, and deep knowledge with us. At Asia, our goals is to grow and connect Angular community across the region, and today's session was another great step forward. If you enjoyed the talk, make sure to like, subscribe, and leave your thoughts or questions in the comment. Thanks again to everyone who joined us, and we will see you at the next NG Azure meetups.
Thank you.
Thank you. Bye.